What's up guys, we are back. In today's video I'm going to be showing you the 5 most important topics in chemistry. By mastering this, I can assure you that you can guarantee you at least 55% of all chemistry questions. And I'm not randomly saying this is a fact. So I decided to split this video into 2 parts. In the first part I'm going to show you the topics and go through the explanation with some examples. In the second part I'm going to grab some of the additions of the IMAT and we're going to analyze the questions on top of what we saw. So if you're nervous and insecure, bear with me until the end and I can show you that chemistry is not black magic, okay? So let's go. Now, they're not in order of relevance. The proportions of each questions can change from edition to edition, but these 5 main topics show up every single year. All right, the first topic of our overview here, we're gonna have atomic structure and periodicity, okay? So you have to be comfortable enough to understand how the elements are organized and how they correlate with the periodic table. Secondly, we have redox reactions. This is no surprise. So basically understanding how does the elements oxidize and reduce, knowing how to identify the patterns. After that, acids and bases. So this shows up every single year. I think it's one of the most important topics of the 5 right now. Right below we have organic chemistry. That's also no mystery. So we're talking about knowing how to identify the organic function, knowing how to count the hydrogens, knowing how to count the number of carbons, and knowing how to bring the molecular structure just based on the name. And finally we have stoichiometry and MadeEasy concepts. Okay, this is going to be very helpful to sort those questions that look complicated but they actually just require this and that knowledge. Okay, so we're going to be going through all that. So right, these are the 5 main topics that will guarantee you at least 55% of the questions. Depending on the year, we're going to have more questions related to that, so that can increase your percentage of accuracy. Now, if you notice, there's 2 blank spaces right below. These are 2 topics that I didn't want to leave aside, so I decided to call it bonus 1 and bonus 2. So I won't be able to cover these 2 topics in this video, otherwise it would be too long. And because they're not part of the 55%, I might just record this extra video separately. If you want this video to come out, just let me know in the comments. And also, don't forget to leave it a like. This helps me to understand if you guys are enjoying this content or not. So let's not lose any more time. Let's jump to the first topic. Alright, so let's just start with atomic structure and periodicity. As I was mentioning, it's a very important topic and it's all about understanding how the elements are organized. So you're gonna have to understand about the subatomic particles. So we're talking about protons, neutrons, electrons, understanding how they are distributed, understanding how they are represented, and also understanding the periodic table. Okay, you're not gonna have access to the periodic table, but there might be statements saying that one element is part of group 1 and the other element is part of group 3. I don't know. And you're gonna have to know why is that important. And I didn't even talk about the ionization energy. This is by far one of the most important subject of this topic. So let's take a look what this is all about. All right, so here we are. But before we get into it, just a quick reminder that this is an overview. I strongly recommend you to take a look at some YouTube video about this topic with a chemistry teacher, but I'm just gonna try to point out what I think is the most important here. So first of all, it's really important for you to remember that the periodic table is organized in groups, all right, in columns that we're gonna call groups, and also in rows that we're gonna call period. So let's take chlorine here as example. There's 2 main important information here that we have to take into consideration. First of all, it's going to be the atomic number, and the other one is the atomic mass. Now, sometimes this can variate, okay, the position depending on the periodic table. In this case, both of them are on top. Some of them will be under it. But what is important for you to know is that the atomic number, it's going to be the exact number of protons that this element has. Okay, the protons will be located inside of the nucleus along with what? With the neutron. Okay, but this does not take into consideration that, but the atomic mass does. So basically this is going to be the combination of protons and neutrons. Later on, you're going to see that this is going to help you to find the molar mass, okay, of the elements. But let's just hold this information for a second. And this one here is going to be important because most of the elements in the nature, they want to be stable. So they're going to tend to have the same number of protons as their electrons. So if you know the number of protons, you're going to know the numbers of electrons. But if you're talking about ions, positive or negative, you have to take that into consideration while calculating the number of electrons. Now, I don't know if you noticed, but as we move down and to the right, the elements start getting heavier and heavier. Okay, we start here with hydrogen with the number 1, and then we just go down 7, 9, 22, 24. Now, the other important thing that is not that straightforward to see is that as we go below, okay, line by line, row by row, we're going to have more electronic layers in this atom. And if you think about it, it makes sense because as we move down, we have a larger atomic mass, which in consequence, we have a larger number of protons. And if we want to neutralize the charge of this element, we have also to increase the number of electrons. So in order to accommodate all these electrons, we have to increase the number of electronic shells. And the third important thing for you to remember is that as we move to the right, each group will increase their number of electrons. Now, I need you to digest this information in order to be able to apply some important properties here, like electronegativity. So electronegativity is the ability of an element to attract electrons. And when speaking of that, there will be 2 things that will influence the electronegativity of an element. The first one will be its number of layers. As more layer as an element has, less electronegativity it is. Because who's going to attract the electron? It's going to be the nucleus. It's going to be the proton. So as more layer as you get, as far as the electrons get from the nucleus. All right. So if I told you that we're going to have more layer as we go down, the electronegativity will be stronger as we go up. And secondly, the weight. Okay. So as heavy as an element is, that means that it will have more protons. It makes sense to think that as heavy as an element is, as more electronegative it will be. And if I told you that you're going to increase the weight as we move to the right, we know that the electronegativity will be strong as we move to the right. The electronegativity will increase as we go to the right and as we go up. And why is this all important? Because when talking about the ionization energy, they're going to follow the same path as the electronegativity. So in this other chart here, we can see this pattern. So the electron affinity, okay, it's going to increase from the left to the right and from down to up. The ionization energies will be the same. If you don't remember what is the ionization energy, it's basically the energy that we need to remove one electron from that element. So it makes sense to think that the elements that has more electron affinity, they will hold more into that electron than other ones. So I know this all can seem a lot confusing, so I'm gonna leave a link below of a chemistry teacher that I think it's really good. But once again, we have our element here, and it's important to remember that the higher number is our atomic mass. It's gonna be the mix between protons and neutrons, and the smallest one will be the proton number, okay? So we might see things like this. For example, we have an X element, okay, it doesn't really matter. It's going to show us the number of the atomic mass. And then right below, we're gonna have the atomic number. It's going to be smaller. Now, even if you don't remember the order of them, always the smallest one will be the number of protons. And finally, something that I want you to remember, we're not going to have time to go through all this, okay? But I need you to remember how to distribute the electrons. So if I tell you that chlorine has 17 electrons, how will you organize and distribute all its electrons? You have to remember that little rule here, okay? So you're going to have to follow these configuration rules. So I suggest you to write on Google or on YouTube electronic configuration rules, because this will be important. So just as example here, we have hydrogen that only has 1 electrons. We know that he only have 1 layer. That's what the number 1 is saying. And that the sublayer is going to be S and will only accommodate 1 electron. When talking about the chlorine, we're going to have something like this, okay? We're going to have 3 layers, and it's going to reach the sublayer P, and it will accommodate 5 electrons. So don't forget, the sublayer S can accommodate 2 electrons. The sublayer P can accommodate 6, okay? And the sublayer D can accommodate 10 electrons. If we know that in their valence shell, okay, that will be this one here, the third one, we have 7 electrons. We know that this element here is really looking forward to get 1 more electron, so it can stabilize in their 8 electrons. So very quickly, let's take a look at an example here. So 2023, we had this simple question. So the element A can be represented by, and then he gives us an equation. So 2x plus 2, and then x here, and then 2 plus. So here we know that we're talking about that element A is an ion, and it's missing 2 electrons. How many electrons are represented in this ion? And then the answers are all in equations as well. So, okay, what does this represent? Once again, this represents the number of protons plus the neutrons, okay? And what does this represent? The number of protons. So how many electrons does one element has? It's basically the same number of protons. But in this case, it's important to notice that this is an ion and it's lacking 2 electrons, okay? We have 2 plus. So to represent the number of electrons, we're going to have to represent it by this, x minus 2. This is just a distractor, okay? So letter A is our answer. Now, question 43, 2023, this is where things start getting more interesting, okay? So which of these elements has the highest first ionization energy? So remember, what is ionization energy? It's basically how hard it is to take 1 electron from an element. So we have all these options here, and then it's showing us the Z number. Remember, what is the Z number? It's the number of protons, okay? So what I'm gonna ask you to do every time you see a question like this, you're going to have to make the electronic distribution. Why? Basically because by doing that, you can figure out how many layers this element has. So let's take a look. Okay, neon have 10 electrons. So we have 1s2, 2s2, 2p6. Perfect. It does have the layer 2 completely full. All right, lithium. Okay, we're gonna have 1s2 and 2s1. Why? Because we only have 3 electrons. We see that we also have 2 layers, but this layer is not complete. Next one, sodium. We're gonna have 11 electrons. It's gonna look like this, but with the third layer, S1. Okay, argon, we're gonna have 3 layers, and these 3 layers are perfectly complete. And potassium, 3 layer as well, but we're gonna have a subunit here with only 1 electron. So by just looking at the electrons and the number of layers, who's going to be the one that has the highest ionization energy? So this one, and this one, we can already see that it will be very easy to remove this electron, because it's asking us, it's begging us to remove this 1 electron that is doing nothing in this subunit. So this leaves us to these 2 options here, neon and argon. They both have their subunit units, okay, in their layers complete with the electrons. But the one that will be harder to remove the electron will be the one that has their electron closer to the nucleons, okay? So in other words, the one that has less layers. In this case, neon. So letter A is what we're looking for. Second topic we have here is stoichiometry and the mole concept. So as mentioned, this is the mathematical foundation of chemistry. If you're not comfortable with a mole, you might struggle a little bit. So this part of the IMAT will test your ability to use balance equations to figure out how much stuff that we can take from there. All right, so I'm gonna go through quickly, just reminding some important points. Important to remember that mole, it is basically a unit that was created to represent a large number of things, of particles, okay? We're talking about atoms or molecules or even ions. And it might be important to remember that no matter what we're dealing with, atoms, molecules, 1 mole of that thing will be this number here, okay? That's called Avogadro number. And another important thing to remember here is this little formula. If you want to figure out how many moles you have, you're gonna have to split the number of mass, okay, in grams of whatever you're dealing with by its molar mass. So remember the molar mass. In order to find the molar mass of an element, you're basically gonna need the number of mass of this element. And if you're dealing with molecules, you're going to have to combine all the atomic mass of each element. Second important formula here to remember is the molar concentration. Okay, so think as concentration of anything. Basically, the concentration of anything is going to be the mass of the solute divided by the volume. Okay, so if you're making a chocolate milk, for example, as more chocolate powder that you put, as stronger as it gets. The same thing here, but we're talking about molar concentration. So what is our solute here? It's going to be the number of mole. So you're going to split that into the volume. By doing that, you're going to find the molarity of that solution. And third, the most important formula here is to understand the relation between concentration and volume. So let's say, for example, the question brings you a situation where it gives you a solution and it dilutes later on and wants you to figure out what is the concentration, okay? What is the molar concentration? You can use this formula to find out that. So let's put that formula into action. Question 37, 2024. How many milliliters of water must be added to 15 milliliters of a 0.25 moles solution of sulfuric acid to obtain a 0.0 moles of solution? So what are the information that we have? We have basically the volume, okay, the initial volume of 15 milliliters. We have the information of concentration, okay, at first and at the end. And we want to find what is the final volume, okay? Actually not, we want to find how much was added. All right, by organizing these informations into this formula I showed you previously, we're going to find this volume right here. So 0.25 times 15 milliliters equals 0.0 moles times whatever volume we should have here, okay? By doing that, we'll find 75 milliliters. Is that the answer? No, that's the final volume. And what was the question? How must be added to 15 milliliters, okay? How much was added? 75 minus 15, okay? That will lead us to 60 milliliters, okay? So our answer here is letter A. Right, question 38 here, 2024. How many ions of sodium moles can be found in 250 milliliters of a 1.2 mole solution of this? Right, so how do we sort this question? We have the concentration here in moles, we have the volume, and we want to find out the number of moles. So remember, to find the mole concentration, we have to divide the number of moles by its volume, but we don't have this information. It's basically a mathematic move here. But will that be the answer? No. It's important to pay attention to this detail here, okay? How many molecules of sodium do we have? 2. So we're gonna have to remember that this element, okay, will dissociate and will release 2 ions per molecule. So our answer will be this mathematic move plus 2. By doing that, we're going to find 0.3 moles. Okay, we basically put into that formula that we had before. So I'm multiplying here because it's almost like I moved the volume to the other side of the equation and I found this number of mole. This is not our answer. We're gonna have to multiply by 2 because this is the dissociation formula. And by doing that, we're gonna find the correct answer being 0.6. All right, so last question here from this topic. Question 45. Carbon and oxygen can react at high temperature to form CO2. Assuming that the relative atomic mass of the carbon is 12 units, the relative atomic mass of oxygen is 16 units, and the yield of the reaction is 100%. What happens when 9 grams of carbon reacts with 36 grams of oxygen? Basically, this is a question where we have a limiting reactant, okay? Let's figure out who is it. Okay, so first thing here, let's organize this equation. So carbon plus oxygen forms CO2. So let's figure out how much molar mass that we're gonna need to form this. So it gave us the atomic mass of each element. So basically that is the same as the molar mass, okay? But just pay attention that the oxygen has 2 atoms, so that will increase the molar mass into 2. So it's going to be 16 plus 16. So we're gonna need 12 grams of carbon and 32 grams of oxygen in order to produce 1 mole of CO2. How much was given to us? 9 grams of carbon and 36 grams of oxygen. So we know that we have less carbon that we should to produce 1 mole. What does that mean? That means that we're going to produce less than 1 mole than CO2. Why? Because carbon is limiting this. So to find out how many moles we have of each element based on each grams it was given to us, we're just going to split 9 grams the molar mass here. So this 9 grams will represent 0.75 moles, and this 36 gram that was given will represent more than 1 mole. Okay, but that doesn't matter. Having more oxygen will not matter to the reaction because this is going to be the guy that will lead it. After we have this, the final step is to find out the molar mass of the CO2 of the product. Okay, and by doing that, we'll find out that will be 44 grams of mole. Okay, this is the amount of grams we should have in 1 mole. We will not produce 1 mole, we will produce 0.75 moles. Okay, because carbon will be the limiting reactant. So the final step we have to do here is to multiply 0.75 by 44. By doing that, we get 33 grams of what? Of CO2. So once again, letter A is the correct option for this question. Now, there's plenty of different ways of sorting this question here. This is one option, but if you have a different way of sorting this question, perfect. All right, so third topic of our video here, redox reaction. Also very important, and what do you need to know? Okay, you're gonna have to be able to assign oxidation number to atoms or molecules. So there's a couple of rules you're gonna have to follow, but there will be so many straightforward questions that will only require this from you. Now, first of all, it's important for you to know how to identify who oxidates and who reduces. So basically, the element that oxidates is the one that loses electron. Okay, so it'll become an ion with positive charge. Why? Because if you remove the electrons, it will have more protons than electrons. The elements that will reduce will be the other one, the one that receives electrons. Okay, so it will have more electrons than it should. So that's why it will also become an ion, but with negative charge. So that's the first thing, knowing how to identify who oxidates and who reduces. There's another important concept that you have to know and understand. That is the reducing and the oxidizing agents. So this can be a lot confusing for a couple of people because it's kind of the opposite. It's the other way around. So the reducing agent will be the element that oxidizes. His role is to guarantee that the other element will reduce. In order to do that, he's the one that has to oxidize, okay, because he will donate that electrons to that element. Same thing goes with the oxidizing agent. Oxidizing agent will reduce, will be the element that reduce, and that will stimulate the oxidation of a different element. There's just 2 words here to try to memorize: oil rig. So oxidation is losing and reducing is gaining, okay? Gaining what? Electrons. Now I'm gonna give you the key information that you need in order to be able to assign the oxidation number of the elements. So first thing to know is that some elements has some predictive oxidation number. So single elements, okay, they will have oxidation numbers 0, like carbon, for example. In molecules, they're all bonding with other atoms of the same element. They will also have oxidation number 0. Trust me, this is going to be very important. Now, we can also have this element here that will have a usual oxidation state. Now, group 1. Remember group 1 from the periodic table? We're going to have elements like lithium, sodium, okay? They're always going to have a NOx plus 1. Group 2 of metals, okay? The group 2 will have a NOx plus 2. We're talking about magnesium, we're talking about calcium. And now, most important, oxygen and hydrogen, okay? Oxygen usually is going to be -2 because it will have the tendency of attracting 2 electrons for itself. Next, we have hydrogen. That's usually going to be +1. We have an exception here, and also a very important exception. Every time we have a hydrogen bonding with a metal, the hydrogen will have the negative charge and the metal will have the positive charge. And after that, the 2 other elements that is important for you to remember is that we're going to have fluorine and chlorine always being -1. Okay, little exception here for chlorine. So let's put this knowledge into action here. Okay, we have a classic question, shows up a lot, and it's basically asking us, in which of the following reactions does HCl act as a reducing agent? Okay, so important, reducing agent. It wants us to identify in which one of these equations we're going to have the HCl being oxidized. Okay, so in order to do that, what I recommend is to go through each one of them and identify its NOx. Let's take, for example, here the first equation, okay? We have this first molecule here. I don't know the oxidation number of this little guy here, but I know the oxidation number of oxygen, okay? That is -2. If I have 2 atoms, that means that will be -4. So this guy here has to be +4 because the goal here is to equal 0 in the end of the day. We do the same thing to the other ones. So I have already done this, so I'm just going to jump here because it will be easier to identify. So let's pay attention to this equation once again. We have the chlorine here with -4, and then he just jumps to -2 here and 0 here. So he's clearly as well oxidizing because he's losing electrons. Okay, let's take a look at the other equations to see if that also happens. So we have chlorine here with -2, chlorine here with -2, 2. Chlorine minus 2 here, minus 2 here. We have minus 1, and then we have minus 6, minus 6. So the only one where we can see that the chlorine is being oxidized is in this equation here. So letter A is the correct answer because the HCl here is being the reducing agent. So it's oxidizing in order to guarantee that the other molecule will reduce. In this case, this guy here is reducing, as you can see. So he started with less 4 electrons, and here it's going to have only less 2 electrons. Okay, so this other question here is very similar to the other one, but it's quicker than the previous one. So we have question 45 saying that this reaction is used in the extraction of titanium from its ore. So we have this equation line here. Which substance is or are the reducing agent in the reaction? Okay, so once again, talking about the reducing agent, we want to identify the one that is oxidizing. So let's bring this equation here, and let's bring as well its oxidation number. We know that oxygen is minus 2, so we multiply by 2, we get minus 4 plus 4. In this case here, we have pure element, so 0. And then we have carbon, 0 as well, okay, pure element. And then in the other side of the equation, what do we have here? We have chlorine with minus 4. Why? Because it's minus 1 times 4 minus 4, and then plus 4. What about the other element here? We know the oxygen is minus 2, so that forced the carbon to be plus 2. So what's happening here? Who's oxidizing? The carbon. The carbon is oxidizing because he started from 0, and at the end of the day, he lost 2 electrons, okay? So he oxidized. In other words, he's the reducing agent. So letter A is also our answer. All right, guys, so for topic here of our video, we're gonna have acid and bases. Really important, perhaps one of the most important for us. And what do you have to master for this, okay? Basically 3 things. The theories, you have to understand clearly the 3 different theories and the differences between them. Also the pH scale, knowing how to make basic calculation involved in this. And finally, know how to identify the strength of each acid, okay? If you're talking about oxyacids or if you're talking about hydroacids. So let's go take a quick look about these subjects here before we go to the questions. All right, so I went for a little break and I realized that this video is already over 20 minutes. That's a lot more than I was planning. So, okay, what we're gonna do here is that I'm gonna summarize the main topics here, okay, and I'm gonna drop some links for some good YouTube videos for you to study. So as I was mentioning about acid and bases, okay, what is important for you to keep in mind is to know how to distinguish the 3 main theories. So there's a couple of differences between them. It's important to be aware of the limitations of each theory and to realize how wide they get as they evolve. So I recommend you to deep into some video because this is really more about understanding than to memorizing. Other than that, still talking about acid and bases, it's important for you to know how to identify the strength of the acids. So there's 2 types of acids, and I'm just going to focus right now in the oxyacids, the one that has oxygen in the formula. So there's a little rule here that you can apply. So whenever you have an oxyacid like this, for example, and you grab the number of oxygen of this oxyacid and you take the number of hydrogens from it, that will determine the strength of this acid. Okay, so this example here, so we have 4 oxygen and just 1 hydrogen. So 4 minus 1, we're gonna have the number 3. So if you have a number equal or above 2, that is strong acid. Okay, so this is a very strong acid. If you have a number that equals 1, this is a moderate strong acid. And if you have a number that equals 0, this is a weak acid. Okay, there's one exception that is important for you to remember, that is the carboxylic acid. So if you remember the formula, it's going to be H2CO3. So if you do the math here, you're going to find the number 1. It is not a moderate acid, okay? It is a very weak acid. So just remember this. The third point that will be important for your preparation about acids and bases is to know how to do basic math here with pH. So there's this formula here for strong acids. So it's going to be the pH equal the minus log of the concentration of this acid. I know it seems a little bit hard, but trust me, it is not hard. I'm going to try to find a good video so you guys can have an idea about this. But there is one example that I bring here. So this question from 2022, question 47, says that if we have, okay, 0.365 grams of hydrogen chloride and dissolve this in 10 liters of water. Okay, so we're gonna have a solution of 10 liters. What will be the pH of the HCl? Basically, in order to answer that, you're gonna have to use that formula, but first you're gonna have to try to find the mole concentration. So it's going to require some of the knowledge that we have already gone through. First of all, understand the molar mass of HCl, okay, and the question gives this information. It's going to be 36.5 grams. So what this means, that means that every time I have 36.5 grams of this acid here, I'm gonna have 1 mole. Okay, but do I have that? No, I only have this small amount here. Okay, after that, you're going to have to do the math here to see how much moles do I have in this solution. Okay, you're gonna find 0.01 mole. Do we need this? We don't need this. We need to know the mole concentration. In order to do that, we're gonna have to apply in that other formula that concentration is equal moles divided by the volume, and that will lead us to 0.01 mole per liter. That is the concentration. This is what we're going to use in that formula that I just showed you guys. So in order to be able to use that, you're going to have to transform this into explanation, and then you're going to have to apply just a single rule of log calculation. So by doing that, that will lead us to pH equal 3. Other than that, you're going to find questions like this that will only test your understanding of the theories that I mentioned, so Bronsted-Lowry, and then you're going to have to identify. Also, there will be other questions like this that will bring you an example of an equation and ask you, okay, so in this case here, the ammonia, for example, behave as what? So if you're aware of the 3 theories, it will be very easy for you to spot that the ammonia behave here as a base. And we're going to also have questions like this one here, 35 from 2023. So a pH meter, it's used to test 0.1 mole of solution of the following components. Okay, so this is just an instrument that they test to see what is the pH of the solutions here. So we have acetic acid, okay, that is basically vinegar. We have a salt here. We're gonna have sulfuric acid. We're gonna have a base here, and then we're gonna have this other acid as well. So which of the following correctly lists these solutions in order of increasing pH? So it wants the stronger acid into the weakest. Why? Because if you remember, pH goes from 0 to 14 as higher as it get the pH, as basic as it is the solution. So as you guys know, vinegar is a very weak acid, and if you go through that little rule that I told you, you're gonna see that it is really weak. The next one, we have a salt. You guys know that salt is not an acid, but it can behave as an acid depending on the situation. So let's just hold this information for a second. After that, we're gonna have the sulfuric acid. It's a very strong acid, and then we're gonna have a base. Okay, so this is a very strong base. So by just plotting this, you can already predict that this will be the highest. Okay, so this will be at the very end of the queue, would probably be letter A or letter E. Right below, we're gonna have another acid that is very strong as well. But the question is here, which one should we put at first? Okay, number 5 or number 3, because clearly these are the stronger acid that we have here. Important detail here, okay? If we go through our little rule, we're gonna figure out that they have the same number. We're gonna figure out that they have the same number of strength, that is number 2. But because we have 2 hydrogens in this molecule and here only 1, when we create solutions out of it, this will be way stronger because it will have 2 hydrogens ions. All right, so this is just another thing for you to keep in mind. So we would put 3 and then 5 and then 1 and then 2. Okay, and finally 4. Finally, the next question that I brought here about acid and bases, this is a very interesting one. It talks about which of the following components forms an hydroxide when reacting with water. So let's take a look at the options here. So they are all oxides because they have oxygen in their molecule. But something that I didn't mention here is that every time we have an oxide that is binding with a metal, whenever we have this in water, it will create an hydroxide. And what about the other ones? Well, when we have these mixed with water, this will create different types of acids because these are not metals. So moving on, the last topic that I bring to you guys is organic chemistry. This is actually pretty fun. I don't think many people struggle with this topic here. I just want to call attention to a couple of things. So it's really important for you guys to be aware of the functional groups, knowing how to identify them, be aware as well about isomeries, and knowing about nomenclature and structures because the IMAT will require this. So you're gonna have to master these, okay, and understand these properly. Also, know how to identify the functions, okay, by their molecular structure, because we're gonna have questions like this, for example, okay? So which one of the following function groups is present in the paracetamol? So you're gonna have to look at this and look at the options here and see that this is not an amine, okay? This is amide. Why? Because we have an oxygen close by. So these type of things are usually things that trick people, especially if you're nervous, okay? So train your eyes to identify the functions correctly. So we're gonna have questions like this, for example, that are very common, that will ask you which of the following compounds contains the most hydrogen atoms. So you're gonna have to grab the name, you're gonna have to create the structure, and to count the number of hydrogens of each one of them, okay? Taking into consideration that this is a cyclohexane, taking into consideration that we're going to have radicals right here, and that we're gonna have some other organic functions right here. The same go with this other question here. So a carbon-oxygen double bond is not present in which of the following molecules? But this is a little bit easier. You can just tell by the names, okay? So identify that this is an acid, okay? So we're gonna have a double bond. Identify that we're also gonna have a double bond right here. Also here an acetone. Why? How do I know that? It's because of the organic functions. The only one that will not have will be the first option here. And you're going to know that because you know that ether is one of the organic functions and it does not have a double bond. And the last question I'm going to bring to you guys is this one here, question 46 from 2021. This is pretty fun actually. Vitamin B5 has the structure and then it shows you which of the following function groups are contained in the molecule of vitamin B5. This is pretty fun actually, but you have to have your eyes well trained to identify these organic functions and see which which ones are present here. So we have a carboxylic acid right here. Okay, we're gonna have a amide right here. We're gonna have an alcohol here, another alcohol here. Okay, so nothing more than that if I'm not mistaken. So train your eyes. So guys, this is the end of the video. I know I rushed a little bit at the end. I'm gonna be releasing very soon the second part where I'm just gonna go through pretty quick some of the previous IMAT editions and showing you that all these topics that we talked today are present in the exams. So if you enjoyed this video and appreciate what I'm doing, don't forget to like and subscribe to the channel if you're new. And don't forget to let me know in the comments if you want me to release the next video with the extra bonus topics. So I see you guys in the next one.